Hello everyone, I am Dr. Parameshwari, Assistant Professor, Department of Mathematics, Vardhaman College of Engineering. In this video, I will explain about the Laurent series. So, if f of z is analytic in a ring-shaped region R, bounded by two concentric circles C1 and C2 of radii R1 and R2, and here radius R1 is less than R2 and with the center at Z0, then for any Z in R values. That is, here Laurent series expansion is given. F of z is equals to summation n is equals to 0 to infinity an z minus z0 whole power of n plus summation n is equals to 1 to infinity bn upon z minus z0 whole power of n, where an is equals to 1 upon 2 pi I contour integral c f of t upon t minus z0 whole power of n plus 1 into dt, and bn is equals to 1 upon 2 pi I contour integral f of t upon t minus z0 minus power of minus n plus 1 into dt, and here c being any curve in R encircling C1. In previous video, I already explained about the Taylor series, and in this video, I am explaining about the Laurent series. Here, difference between the Taylor series and the Laurent series is Taylor series converges in a disk around the point A, and the Laurent series converges in an annulus around the point A. Now, for better understanding of the Laurent series, we will solve some problems. Now, here I am taking one problem, that is expand f of z is equals to 1 upon z minus 1, z minus 2 in the region modulus of z is less than 1, 1 is less than modulus of z less than 2, and the third one is modulus of z is greater than 2, and fourth one region is 0 is less than modulus of z minus 1 is less than 1. That is, here I am explaining this f of z function in a different region, that is first, second, third and the fourth, that is the four different regions. Here I will explain using the Laurent series. If we want to use the Laurent series, first we have to simplify the f of z value, and in this first f of z is given data is f of z value is 1 upon z minus 1 and z minus 2. Now we want to use the Laurent series, means first we have to separate this given function using the partial fraction. That is, if we want to separate this function using the partial fraction, means here this partial fraction terms we are dividing into a upon z minus 1 plus b upon z minus 2, and we know how we separate the partial fraction terms, and after separating the partial fraction and simplifying this equation, we will get the a value is minus 1 and the b value is 1. Now, here I will substitute this a value minus 1 and the b value 1 in a given function, that is given f of z is converting into minus 1 upon z minus 1 plus 1 upon z minus 2. This is the given function. Using the partial fraction, here I separated. After separating this here, first one we expand this given in a form of z. That is, what is the region here given here? Modulus of z is less than 1. That is, here I will first consider the first region, modulus of z is less than 1. And what is the meaning of this modulus of z is less than 1? That is, z value is lesser than the all values of 1. That is, here first, so here f of z, here we have this one is our f of z here. And in this f of z, we are using this region modulus of z is less than 1. That is, f of z is equals to minus 1 upon, and in this if we want to separate the Laurent series, means first we have to check z and 1, and we know it is clearly mentioned modulus of z value is less than 1. Modulus of z value is less than 1 means 1 is the greater value. If 1 is greater means here we have to take minus 1 common. That is, if we take minus 1 common, here we get 1 minus z plus 1 upon, and we know it is clearly given z and 2, we have the two terms are given, and in z and 2 we know 1 is greater means here 2 is also greater, means here we have to take minus 2 common, and if we take minus 2 common, here we get 1 minus z by 2. That is, here I taken the greatest terms into common. After taking the common, here minus and minus is placed. I will take this term into numerator. If we are taking the denominator term into numerator, here we have to write into inverse. Plus into minus minus, 1 upon 2 as it is, and take this term into numerator, that is here we get 1 minus z by 2 whole inverse, and this is inverse form. Now we have to write this is inverse into summation form, that is this we also write it in summation form. Summation n is equals to 0 to infinity z power of n minus 1 upon 2 summation n is equals to 0 to infinity z by 2 power of n, and this series we also simplified into summation n is equals to 0 to infinity z power of n minus, if we take this 1 by 2 into inside of the summation n is equals to 0 to infinity, and we are taking the separation, that is a z power of n here I am writing, and this term is 2 power of n, and outside of the value is 2 power of 1, that is here we also write it as 2 power of n plus 1, and this is a Laurent series expansion of the f of z value in the region modulus of z is less than 1. Now I will explain about the second region. We have the second region is given in our question. Second region is 1 is less than modulus of z is less than 2, that is here I will write second region 1 is less than modulus of z is less than 2. That is here we have to expand this f of z value in a form of z, and what is the condition here given? 1 is less than modulus of z is less than 2. That is first here given value I will write here, given f of z is equals to, here already I separated this f of z value, I consider this f of z value, that is minus 1 upon z minus 1 plus 1 upon z minus 2. This is our f of z value. Now in this f of z value our condition, region condition is given 1 is less than modulus of z is less than 2, that is this is the meaning modulus of z value is in between 1 and 2. In between 1 and 2 means here we know clearly z value is greater than 1. Z value is greater than 1 means we have to take the z common in this expansion. If we take z common in this expansion, 1 minus 1 by z here we left plus 1 upon, and we know clearly modulus of z value is less than 2, that is the 2 is the greater term, that is here I want to take the common term minus 2, that is minus 2. If we take common we will left 1 minus z upon 2. Now after taking the common terms, here we have to take these terms into numerator. Minus 1 by z here I am writing as it is, and this term we are taking into numerator means here we will get 1 minus 1 by z whole inverse plus into minus 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 1 upon 2 1 minus z by 2 whole inverse, and this is the Laurent series in a form of z, and we know this series is in a form of a binomial expansion. Now I want to use the summation form, that is this we write in a summation, we also write it as summation n is equals to 0 to infinity 1 upon z whole power of n minus 1 upon 2 summation n is equals to 0 to infinity z upon 2 whole power of n. Now here 1 upon z here I want to take the inside of the summation, then this we also write it as minus summation n is equals to 0 to infinity 1 upon, and in already we have the z power of n is given, so z power of n and the z power of 1, that is we write both the combination, that is z power of n plus 1 minus, if we take 1 by 2 is inside of the summation, we will get summation n is equals to 0 to infinity, and this we also write it as z power of n, and in this 2 power of n, and already we have the 2 power of 1, that is the 2 power of n plus 1, and this is the Laurent series expansion of f of z in a form of z using the second condition. And here condition is if 1 is less than modulus of z is less than 2. Now I will explain about the third condition. What is the third condition is given question? Third condition is given modulus of z value is greater than 2. That is here I will write the third condition, modulus of z is greater than 2. Modulus of z is greater than 2. And here we know the given value of f of z is, I will write the given f of z. Given f of z is equals to minus 1 upon z minus 1 plus 1 upon z minus 2. This is the f of z value. Now in this our region is modulus of z is greater than 2. That is, whatever the z values is there, all values are greater than 2. And in this z and 1, we have to take the greatest term into common, that is z is greater, then it is clearly we have to take the z common. And if we take the z common here, we will get 1 minus 1 upon z plus 1 upon, and also we have the two terms z and 2, and in this z and 2 clearly z is greater, that is here I will take z common, then we get 1 minus 2 upon z. After taking the common here, we are writing this in a binomial expansion form. Binomial expansion means we have to take the denominator terms into numerators, that is minus 1 upon z, and take this term into numerator. Here we will write in inverse form, that is 1 minus 1 by z whole inverse plus 1 upon z, 1 minus 2 by z whole inverse, and this is binomial. Now this expansions we are writing in a summation form, that is minus 1 upon z as it is. This we also write it as a summation n is equals to 0 to infinity 1 upon z whole power of n plus 1 upon z summation n is equals to 0 to infinity 2 upon z whole power of n. And if we take this z into inside, this minus as it is summation n is equals to 0 to infinity 1 upon z power of n, and z power of n we also write it as a z power of n plus 1 plus, if we take 1 by z into inside of the summation, summation n is equals to 0 to infinity 2 power of n upon z power of n, and z power of 1 we also write it as z power of n plus 1, and this is the binomial expansion we using in a summation form. And now finally this is the Laurent series expansion in the region mentioned modulus of z is greater than 2, that is if modulus of z is greater than 2. Here after explaining about the third region, here I explain the fourth region, that is 0 is less than modulus of z minus 1 is less than 1, that is fourth region. F of z value, already we have the f of z value, f of z is equals to minus 1 upon z minus 1 plus 1 upon z minus 2, and here our region is given 0 is less than modulus of z minus 1 is less than 1, that is we want to expand the given f of z in a form of z minus 1. In a form of z minus 1 means here we have the first step, we have to substitute this z minus 1 value is equals to w, and this z minus 1 is equals to w means z is equals to w plus 1. Now here I will replace all these values in a f of z value, that is f of z is equals to minus 1 upon z minus 1, already we are taking the z minus 1 value is w, that is z minus 1 value is w plus 1 upon z, we have the z value is w plus 1, that is w plus 1 minus 2. Now after simplification of this f of z value, minus 1 upon w plus 1 upon w minus 1. This f of z is in a form of w, I will write in a binomial expansion form, that is minus 1 upon w as it is, and we know clearly modulus of z minus 1 value, that is the w value is between 0 to 1. Between 0 to 1 means here 1 is the greater term, means here I will take the minus 1 common. If we take the minus 1 common here, 1 minus w. Now this 1 minus w we have to taking into numerator, that is minus 1 upon w plus into minus minus 1 minus w whole inverse. Minus 1 upon w writing as it is, and this 1 minus w whole inverse in a form of series, that is summation n is equals to 0 to infinity w power of n, and we have the w value, that is the w value is z minus 1. Then here I will replace the w value z minus 1 minus summation n is equals to 0 to infinity w value is z minus 1 whole power of n, and this is the expansion of the f of z in a form of z minus 1 using the Laurent series, and we have the condition is if 0 is less than modulus of z minus 1 is less than 1. Like this, we have to solve the f of z function using the Laurent series in a particular region. Thank you.